Welcome or welcome back to 3 Inquisitive Kids. In this video, we'll be talking about symmetric figures. This is lesson 4, our last video of this chapter, and as you can see in our course outline, we've learned about symmetry and isosceles triangles and perpendicular bisectors and so on. So in this lesson, we're going to be concluding what we know about symmetry and some of everything. Our learning goals for today is to be able to create symmetrical designs based on one figure and understand the reflection and transformation of figures. So this lesson will be a little bit more visual and hands-on. If you want to do any of the activities, feel free to try it. So this is paper cutting, right? Like, a lot of people, they like to do this, and I know some cultures, they make patterns like this at a certain holiday. And these figures all have a line of symmetry, because usually you first fold the paper and then you cut it in a specific way. And here are more symmetric figures. Designing with symmetry. Find the original figures the following figures came from. So here we have 4 different designs. And what they mean by the original figure is like the very basic picture you started out with before any reflecting or before any symmetry. So for the first one, the original figure, when you break it down one by one, it would be just one flower petal. For the second one, it's just one rhombus. For number 3, it's one of these arrow-like pictures. And for the last one, it's the hexagon with this arrow-like picture. And are any of these figures themselves axis symmetric? Number 1 is not. Number 2, number 3, and number 4 are all axis symmetric figures. So which of the following figures can be created through symmetry? Remember, there are lots of different types of symmetry. So this is our first figure, which is a flower. Its basic figure would be one petal, and this is its transformation process. As you can see, it's getting rotated around the origin. The basic figure for this pattern is one rhombus, and its transformation process is that. What's the basic figure for the screen picture? Well, it's one of these arrows, and this is its transformation process. As you can see, there's one red dot in the middle, which is the point where this green figure is rotating around. The basic figure for this last picture is this, as you can see, and this transformation process is also a rotation. Remember, this is rotational symmetry. We haven't really talked about it yet, but we will talk about it later on in 8th grade. Designing patterns using axis symmetric transformations. Here we have flowers. They are axis symmetric. We also have flowers here, and they are also axis symmetric. And these are just some more flower designs with axis symmetric transformations. Look at how many different ways you can reflect one image. If you change the angle of the symmetry of axis a little bit, you can move the image towards the top. So you can basically control where the image is moving. Here's some practice. Given triangle ABC and line L, find the figure that is symmetrical to triangle ABC about line L. Here we have triangle ABC. Remember, we learned how to do this. First, you reflect each point separately, and then you connect the dots. This is, again, a quick overview of what we learned. And this would be A prime, B prime, C prime. Example 2. A residential area wants to build a symmetrical flower bed in a rectangular open space. The design is required to be composed of circles and squares. The number of circles and squares is unlimited. Draw your entire design proposal down below. Well, this isn't really a math problem, it's kind of an art problem. All you have to do is take a rectangular piece of paper and then draw a symmetrical design inside of it. So you're going to make the garden symmetrical. From bird's eye view, the garden would look like this. Of course, this is an example. There are so many different ways you can design this. Do it yourself. Take a strip of paper 30 centimeters long and 6 centimeters wide and fold it every centimeter like an so-called accordion. Draw the letter E on the folded paper. Cut along the marks with scissors. Then unfold the piece of paper, and you will get this. If you don't want to, you don't have to do this, because it seems like it's very specific, 30 centimeters long and 6 centimeters wide. But you can still see how when you unfolded the piece of paper, there are multiple E's because you folded them at first. And if you first folded the paper strip in half vertically, and then continued what we just did, what kind of pattern will you get this time? Is it an axisymmetric figure? So now they're saying to, before you do anything, fold the paper strip in half vertically. What you get is the same thing, except what's different is that there are 2 rows. And yes, they are still axisymmetric. Here are more symmetrical figures. Are they axisymmetric figures? What meanings do these figures represent? And design an axisymmetric pattern by yourself and explain its meaning. A lot of logos and images you see every day are symmetric, and they always have like some sort of meaning behind them. I want you to draw an axisymmetric design yourself and explain what it means. Use 2 circles, 2 line segments, and 2 triangles to design an axisymmetric pattern, and then explain your design's meaning. This is very similar to what we did in the previous slide, except now they have given you your shapes. Here's what some other students did with the shapes they were given. As you can see, you can make all sorts of different things. And that's it to the end of our lesson. I hope you enjoyed this entire chapter, and be sure to come back for our next unit.